once wet world. But here on Earth, for life to thrive, it needs more than water. It needs nutrients.
We tend to simplify that search for what type of nutrients as what we call schnapps.
When people say schnapps, what they're saying is carbon,
hydrogen,
nitrogen,
oxygen,
phosphorus,
sulfur. When we spell all those, the first letter of all of those out, it's called schnapps.
These 6 elements make up roughly 99% of the mass of the human body. In fact, they make up about 99% of the mass of all living things. If life, as we know it, ever existed on Mars, finding schnapps was key. Could Curiosity, a laboratory on wheels, find schnapps? The rover scooped up samples of Martian soil to decode its chemical composition.
What we found was a diverse chemistry that included carbon, hydrogen, some nitrogen, oxygen, and sulfur, and chemical energy available for life if it had ever lived there.
That's really been the big discovery of the Curiosity rover mission.
Curiosity found the ingredients necessary for life to emerge, but not life itself.
Curiosity has not, in fact, detected evidence for life because it does not have the instruments designed for that purpose.
Perseverance is designed to take the next step in Mars exploration as it ventures into unexplored territory to search for samples of Martian rock in Jezero Crater.
If you want to set yourself up for success for finding ancient life, that is the place to go.
This orbital image reveals what makes Jezero Crater so intriguing.
The key thing that led us to Jezero was this beautiful delta, beautifully visible from orbit. We think that delta must be somewhere around 3 billion years old or older. This delta sits at the end of a beautifully expressed sinuous river channel that came in from the northwest, flowing into the crater rim and filling up Jezero Crater with a lake.
On Earth, deltas form where a river and a larger body of water meet. Sediment, brought in from the river, drifts to the bottom.
Sediments that the river carries they really just fall out and they settle down.
It creates a mud layer at the bottom. Year after year after year after year, it creates these.
Take some of that earthly delta mud, put it under a microscope, and you'll find it's teeming with life. Tiny microbes, among the most ancient forms of life on Earth, arising billions of years before the dinosaurs, and far more resilient.
If you think about Mars, billions of years ago, we cannot hope for any large-scale fossils. We can't really hope for fossil bones. We can't hope for petrified wood. We can't hope for fossilized leaves, because none of that life existed even on Earth before maybe 500 million years ago. The only life that we can hope for on this old ancient Mars is microbial. Now this is where it gets tricky because microbes are tiny, that's what their name says. They're microscopic. And we can't really take microscopes to Mars, but what we can look for are rocks that can be shaped by microbial processes.
And that's what the team hopes Perseverance will find. Fossilized microbes buried in the ancient rocks of Jezero Crater.
There were a lot of very interesting debates among the members of the science team trying to figure out which rocks should we sample. What should we be looking for? And we have one example, only one example, and that's Earth.
So the Perseverance science team set out to study the clues Earth has to offer in rocks about the same age as the ones they will search for in Jezero Crater.
We went to this location in Western Australia where the oldest evidence of life occurs, just so we could see what it actually looks like.
There are ripples around inside.
The strange rippled layers of these rocks, known as stromatolites, are actually the remnants of a form of ancient microbial life.
In a stromatolite, you'll see there's lots of convolutions. They're bumpy and lumpy.
Bumps and lumps of fossilized microbes.
A fossilized community of organisms all packaged together.
There are just a few colonies of living stromatolites left on Earth. Are layers of bacteria.
These often form in shallow water environments where the microbes sort of have something to live on, and they pile up in these layers, one on top of the other, a layer of gooey microbes, bacterial cells that have this sort of mucousy, gooey substance. That gooey substance traps sediment, mud or sand that flows on top of it, and then they grow on top of that again, and that process repeats.
By studying these ancient stromatolites, the team hopes to gain a deeper understanding of what to hunt for on Mars.
When we went out and looked at these rocks, I was very surprised how obvious it was that the structures we were looking at were, first of all, very unusual and very likely to be biogenic, produced by life. This is a kind of a feature that we could see in Jezero Crater with the cameras that we are carrying with us on the Perseverance rover.
This rover has a ton of cameras. We are carrying 23 cameras.